Right, in our last problem here, we're going to look at another kind of common application of our multiplication rule. And as we're going through and we're thinking about these, we are going to be finding products of a bunch of different things. We're going to be kind of bringing in some of the stuff with changing denominators and things like that that we saw in previous examples. So kind of tying everything together. All right, so a new medicine was given to a sample of 25 of Dr. Cleary's patients with flu symptoms. Of the total, 19 reacted favorably, 2 reacted unfavorably, and 4 were not affected. 3 of these patients are selected at random. Determine the probability of each of the following. All right, so all 3 reacted favorably. So the probability that all 3 reacted favorably mean we're taking the probability of the first person being favorable times the probability of the second person being favorable times the probability of the third person being favorable. Right, so let's find some probabilities. All right, so our first probability that the first person is going to be favorable. Well, we had 19 out of 25. Right. And then again, we're just going to multiply all of these guys together. Our second person being favorable. Well, we've already taken one person out of our sample, right? We already selected one of these 19 out of 25. So that means what we're going to have left is we are going to have 18 people left out of 24. So our next one is going to be 18 out of 24. And if we select one more person, right, well, now we've taken 2 out of our original pool. So now we have 17 out of 23. Okay, we're going to go ahead and reduce our fractions a little bit. Both of these are divisible by 6. So that's going to give us 3 and 4. So then if we multiply across what we have left, we get 969 out of 2,300. Or in some of these cases, you might be asked to write your answer as a decimal. So we'll round this to 0.421, right? Or about 42%. We have about a 42% of randomly selecting 3 people that all reacted favorably. This would be a case where we do have dependent events because our first probability does change our second one. So just to kind of throw that in there as well. Right, the first patient reacted favorably, the second patient reacted unfavorably, and the third patient was not affected. So we are looking at favorably, unfavorably, not affected. Right, so first person is favorable, person 2 is unfavorable, person 3 is not affected. All right, so favorable. Just like in the last problem, we have 19 out of 25. Unfavorable. If we go back up to our original problem, there were 2 people that reacted unfavorably, but we have taken one person out here. So we are going to say 2 out of 24. Right. And if we go back up to our original problem, there were 4 that were not affected. Right. So the 4 that were not affected, but we have taken 2 people out, so we have 4 over 23. Then we can reduce this a little bit. 2 and 24, we can divide them both by 2 to get 1 and 12. Then we can do a little more canceling here. Both of these are divisible by 4. 4 divided by 4 is 1. 12 divided by 1 is 3. And then we're just going to multiply what we have left. 19 times 1 times 1 gives us 19. 25 times 3 times 23 is going to give us 1,725, or 0.011. So about a 1% chance that the first patient reacted favorably, the second reacted unfavorably, and the third patient was not affected. Right, so for C, the probability that no patient reacted favorably. Right. So the probability that the first person was not favorable times the probability that the second person was not favorable times our probability that the third person was not favorable. All right, so what that means is these people could be either unfavorable or not affected. Right, so unfavorable or not affected. We had 19 people that were favorable, so our complement of that would be 6 out of 25. Right, we subtract it from 1, or the 2 people that reacted unfavorably plus the 4 people that were not affected gives us that 6. Right, and then our next one, well, we've taken one person out of here, so we're going to have 5 over 24. And then our last one, we've taken another person out, so we have 4 over 23. We're going to do some canceling here. All right, so this is going to get a little bit messy. 5 and 25, we can divide them both by 5, we get 1 and 5. 6 and 24, we can divide those both by 6, we get 1 and 4. And then these 4s will also cancel and give us 1s. And then we multiply what we have left, and we have 1 over 5 times 1 times 23 is 115, or 0.009. Right. Again, depending on what type of problem you're working through, if you don't have to deal with the fractions, you don't necessarily have to go through it this way. If you're just asked for a decimal answer, that's fine. All right, and then for D, the nice thing about D is we can use our answer from C. So remember, if we're looking for at least one, we talked about this in the previous section, our probability of at least one is our complement of none. So we're going to take 1 minus our 1 over 115 that we got from part C, which gives us 114 out of 115, which is 0.991. All right, so again, as you're working through these, pay attention, read the questions carefully. Make sure you're writing your answers in the correct format, whether you're asked for fractions or decimals. And then again, this section is definitely a lengthy section, and definitely has a lot of different things to look at, a lot of different types of problems between the and or, and a lot of definitions between mutually exclusive and independent versus dependent events.